All right, so today we are moving on to Unit 1, Lesson 7. You may have noticed there are no new lesson notes today, so we're just going to get right into the examples. So, number 1, is the sequence F geometric, arithmetic, or neither? So, is the sequence F geometric, arithmetic, or neither? So, it looks better on here. So it looks like they gave us the recursive form. So it's telling us that our starting term is 20 and that each new term is equal to the previous term times 1/2. So the starting term is equal to 20 and each new term is equal to the previous term times 1/2. The key word in this is times. So that makes this a geometric sequence. Okay. Part B, represent the first 5 terms of the sequence F by creating a table and sketching a graph. In order to do that, I'm actually going to use Desmos to help us with that. So I'm going to go over here to Desmos, and it's very simple to create a table. All you do is if you open up Desmos like this, if you hit the plus button, you can click table. So for example, our starting term, our term 0, we know is 20. All right, and they want us to represent the first 5 terms. So we're going to do term 0, term 1, term 2, term 3, term 4. Okay, so the first 5 terms are going to be those terms. So remember, the recursive tells us that each new term is equal to the previous term times 1/2. So each new term is going to be half the previous term. So half of 20 is 10. And then half of 10 is 5. And then half of 5 is 2.5. And then half of 2.5, and you may need to use your calculator if you need to, but it's 1.25. And the thing that I like about using Desmos is not only does it give me the table, but it also automatically shows me the graph. And we can see we had determined that it was a geometric sequence. We can see that that is true from the graph because the graph is clearly exponential in nature. Okay, so that is part B. And that is it for number 1. Okay. Number 2, different sequence. Is the sequence K geometric, arithmetic, or neither? Okay. So here's our starting term. Our starting term is 20. And then our fifth term, our new term is going to be equal to the previous term minus n. Now, at first glance, this may look like an arithmetic sequence because of the subtraction, but there's a problem. Remember, with arithmetic sequences, it requires us to add or subtract the same number each time. In this case, we're not subtracting the same number. We're subtracting n. Now, what is n? N is the term number. So if I want to find term 1, I'm going to subtract 1. If I want to find term 2, I'm going to subtract 2. So the key is I'm not subtracting the same number. So therefore, this is an example of a sequence that is neither. So A is not arithmetic, it's neither. Okay. Okay. Part B, what is the fifth term of sequence K? And to do that, I am once again going to use Desmos. Okay. And I'm going to help myself by creating a table. Okay. So B, I'm going to use Desmos. Okay. So I'm going to insert a table, and I know that my starting term, which remember is term 0, I know that my starting term is 20. Okay. And I want to find the fifth term. So the fifth term is not going to be term 5. The fifth term is actually term 4. Okay. So in this case, okay, notice in this case, if I want to find term 1, that means I need to take the previous term and subtract the term number. So I'm going to take the previous term. Whoops, I hit the wrong one. I'm going to take the previous term and subtract the term number. So 20 minus 1 is 19. Okay. To find the third term, or term 2, I'm going to take the previous term and subtract that term number. So now I'm going to subtract 2. Okay. The next thing I'm going to do is I'm going to subtract 3. So 17 minus 3 is 14. Okay. And then I'm going to subtract 4, which is 10. Okay. So to answer the question, what is, so to answer this one right here, what is the fifth term of sequence k? The fifth term of sequence k, we just figured out, is 10. Okay. And then by doing the table, we now have actually answered part C. We sketched the graph. The graph is right here. Okay. The graph is right here, and you can see this is not a linear, and it's not a exponential graph, so it makes sense that it's neither. So part C, we also used Desmos for. Okay. That's it for number 2. Number 3, is the sequence Q below geometric, arithmetic, or neither? So now the sequence Q is given to us with a graph. Okay, we'll pull it up here so it's a little clearer. Okay, pull it up here so it's a little clearer. So if I make this a little bigger, okay, if I make this a little bigger, okay, we can see this graph here is clearly linear in nature. So if it's linear in nature, that means it's an arithmetic sequence. So sequence Q is arithmetic. Okay. Represent the first 5 terms of sequence Q by making a table. So let's go back and look at the graph. So it looks like our first term, okay, it looks like our first term is going to be, let's see, that looks like 16 to me. So term number and value. So our first term, this one's a little different because we're actually starting with term 1 instead of term 0, and that will sometimes happen. What I want you to do is I want you to assume that we'll always start with term 0 unless it's stated otherwise. And in this case, it is stated otherwise because there is no dot where term 0 would be. So unless it's stated otherwise, assume that our starting term is term 0. In this case, our starting term is term 1, and according to our graph, it looks like it is 16. Okay. It looks like term 2 is 11. So it looks like we're subtracting 5 each time. So that would mean term 3 would be 6. And let's double check that that is correct on the graph. Yep. Okay. So term 4 would be 1. Okay. And term 5 would be -4. Okay. And that is indeed true from the graph. Okay. And that is it for your examples for today.